If you have ever picked up a weight and began doing repetitions, you'll know that your first rep and your last rep are drastically different. During the first rep, you'll feel full of energy, but by the last one, it is as though the energy has just run out. To understand why this is, you need to understand the energy that powers a muscle contraction. The food we eat? The air we breathe? These are definitely components, but the actual process is a little more complicated. Understanding it, though, will give you a significant advantage over the average bro who trains. A muscle contraction requires the muscle cells to have energy. In our bodies, this energy is stored in a specific molecule called adenosine triphosphate, or ATP. ATP is a large molecule, not to mention it is unstable in water, which is bad news since we are made mostly of water. ATP makes up for these drawbacks, though, through the fact that if the third phosphate chain is released, it provides the power for a muscular contraction. Because it is a large and unstable molecule, our muscles can only store enough to power 5 to 10 seconds worth of contraction before they run out. Since only 10 seconds of ATP is stored, the body has 3 generation systems which work in real time to keep these levels topped off. Powering these generation systems and stored in your muscles is a more stable molecule, glucose. It is this glucose which the first generation system turns into ATP, along with some byproducts. Then, the other 2 generation systems turn those byproducts from the first generator into more ATP. One of my favorite shows is The Grand Tour on Amazon. In the Season 1 finale, James May drove a hybrid BMW i3, which is actually a great analogy for this system. The car is powered by electricity, which is stored in a battery. The car can store a limited amount of electricity in this battery, just like your body can only run on ATP and stores a limited amount. Once this runs out, a diesel generator built into the car provides a slow stream of electricity back into the battery. Think of this like your body turning glucose into ATP through its 3 primary systems. The car can't run directly on the diesel, just as you can't run directly on the glucose. It must first turn the diesel into usable energy, electricity, or in our cases, ATP. The main difference, though, is where James May's car has just 1 generator, your body has 3 generation systems which are simultaneously working to keep these ATP levels topped up. Later on, it will become very important to understand that each of these generation systems also operates at a different speed. So hopefully you're following so far. The muscles have a limited supply of ATP. 5 to 10 seconds later, it's all gone. Think of the ATP supply as a laptop with a really terrible battery life. This is why the 3 ATP generation systems of the body are so important to keep the ATP battery topped off. The first generator runs on that glucose that is stored and available in the muscles. Through something called glycolysis, the muscle is able to create 4 ATP molecules from a molecule of glucose using 2 molecules of ATP which it already has. The process is the fastest of the 3. There are also some byproducts left over, which will be exploited later on by the other 2 generators to create even more ATP. Left over are 2 pyruvate molecules and 2 NADH molecules. Now onto the other 2 generators, which, unlike the first one, the other 2 require oxygen to operate. If oxygen is present, these 2 systems can run. The pyruvates can be broken down into 2 more ATPs and even more NADH molecules through the Krebs cycle. This cycle operates at a slower rate than glycolysis, and like I said, very important, it requires oxygen. Then, the third element, the electron transport chain, with the help of oxygen, is able to turn all of these NADHs into even more ATP, such that One very efficient cell in the third step can create 34 ATPs. This is the slowest of the three processes and once again requires oxygen. So out of just one stable molecule of glucose in the muscles, our muscle cells have derived 38 molecules of ATP. With these three processes working simultaneously, a continuous supply of energy is available. Different macronutrients we consume slot into these processes in different places. Only glucose can be used for the first process of glycolysis. However, fat can be turned into glucose within the liver, or else ketogenic diets wouldn't work. Protein, however, must be broken down into amino acids and can only enter into the second process. Imagine that you are walking at a slow pace. There is a certain ATP burn rate demanded by your muscles to fuel this walking pace. As you speed up though, so does the ATP requirement, just like James May's car accelerating. But remember, unlike James May's car which has one generator, our bodies have three, each operating at different speeds. As you increase the ATP demand, eventually you'll hit a point where you burn ATP at a faster rate than the slowest generation process can keep up with. The limiting factor? Remember how I said the final two processes require oxygen? Well, if your body is unable to deliver oxygen quickly enough, these processes can't work and you'll feel out of breath, as your body struggles to keep the Krebs cycle and electron transport chains running. Remember the first process, glycolysis? Well, if you remember, it didn't require oxygen, so it keeps chugging along for a little while. But it also only yields 2 ATPs. What puts a stop to our last remaining ATP generator? Well, as you remember, glycolysis had byproducts. Normally, the other two generators would use these byproducts. But in the absence of enough oxygen, these generators turned off, so the byproducts begin to build up. When the byproducts aren't being used by the other two generators, your cells need to get rid of them quickly, so they turn them into something you have probably heard of before, lactic acid. As the lactic acid builds up, it eventually becomes too detrimental, and the last remaining generator is forced to stop producing ATP, and your car body stops. This is the essence of aerobic versus anaerobic. When you're operating aerobically, you're operating in the presence of oxygen at a slow enough ATP burn rate that all three generators are running. Once your ATP burn exceeds the metabolic threshold, the other two generators can't get enough oxygen and the burn rate becomes unsustainable. When we are running on just the generator that doesn't require oxygen, we are operating anaerobically. The good news is that this metabolic threshold can change. As you train to improve your cardio, you can increase the burn rate, which your body can sustain aerobically, as your body becomes more efficient at delivering oxygen to the muscles. I hope I was able to explain that in a way that made sense. It's a complicated topic, but it doesn't have to be. Until next time.